this tutorial, we're going to go over a basic introduction to probability, and we're going to look specifically at three different types of probability. So first, we're going to work with experimental. Now, for experimental probability, it's mainly based off of our own observation, and I'll let you know what I mean by that with this first example. So here, we have Steve Nash. Now let's say he makes 14 out of 15 free throws during a particular game. What is the experimental probability that he will make a free throw? Well, based on this observation, during a particular game, he made 14 out of 15 free throws. So if he makes 14 out of a total of 15 free throws, that would give us a probability of about 0.93, or rather than having this as a decimal, we could change it into a percent by multiplying it by 100. And another way of doing that is just moving this decimal over 2 places to the right. So we could also say, rather than 0.93 being the probability, we could say 93%. Now right here, you can see three different ways of expressing probability. You can either express it as a fraction, like we do here, or as a decimal, like 0.93, or you could express probability as a percent, for example, 93%. Now with this specific example, the experimental probability is based off of this observation here. So based off of the 14 out of 15 free throws, we could say that Steve Nash has a 93% chance of making a free throw. Now let's take a look at one more example for experimental. So here we have a lemon tree. Now let's say your lemon tree produced a total of 500 lemons this year. 50 of those lemons did not ripen properly. So what is the experimental probability that your lemon tree will produce a fully ripe lemon? Well, if this year you had a total of 500 lemons from your tree, and 50 of them didn't ripen properly, well, if 50 didn't ripen properly, that means we had 450 that did. So for us, the experimental probability would be 450 out of 500. Now we could reduce this fraction to be about 9 over 10. So there's 9/10 of a chance that you'll get a fully ripe lemon from your tree. And again, we could express that in a couple other ways. We could express that as a decimal, so when we do 9 divided by 10, we could get 0.9. Or we could express that also as a percent. So when we move the decimal place over to the right 2 times, or 2 places, we get a 90% chance. So you have a 90% chance of getting a fully ripe lemon from your tree based on this observation. So that's about it for experimental probability. Let's take a look at another type. So this next type is going to be theoretical probability. So with theoretical probability, there's a set number of possible outcomes that could happen with a particular situation. And depending on a certain event, you may only use part of those outcomes, or some of those outcomes may be possible within your event. Now, to get a better understanding of what this actually means, let's take a look at a 52 card deck. Now, for example 3 here, you draw a card from a standard 52 card deck. Now, the event that's taking place is you're drawing a card. Now, with this event, there's 52 total possible outcomes. Since there's only 52 cards, you could only have 52 different things happening. at the most. Now, so that means for us, the total number of outcomes that could happen are 52. And now, let's see specifically which event we're looking at for drawing a card. So the first question is, what is the probability that you will draw a heart? Well, drawing a heart would be our specific event in this case. Now, with a standard 52 card deck, there are 4 suits, and they're all equally divided up within the deck. So since a heart is one of those suits, that's like 1/4 of the deck. So we could say that the probability of drawing a heart is 1/4, or we'd actually count up the total number of hearts within the deck. Now, since a standard playing card deck has 2 through 10 plus an ace, and then also 3 face cards, that will give us a total of 13 hearts. Now, if we reduce this fraction, it also gives us 1/4 as our probability. And again, you can express this as a decimal or percent if you wish. So that's the probability of drawing a heart. Now, what's the probability of drawing a 10 of clubs? So just a standard notation is normally you write P for probability, and then in parentheses you'll write the actual event. So for this event, we want to draw a 10 of clubs. Now within a standard deck, there's only one 10 of clubs. So out of the 52 cards we could possibly draw, only one of them will give us the 10 of clubs. So that gives us a probability of 1 out of 52. Now we have one more event. What's the probability of drawing a king? So in a standard deck, there's one king for every suit. Now since there's 4 suits, that means there are 4 kings. So out of the 52 possible cards we could draw from, only 4 would give us a king. So the probability of drawing a king would be 4 out of 52. Or we could reduce that fraction to be 1 out of 13. So there's a basic introduction for the theoretical probability.